All right, next section is to identify zeros and what are called multiplicities of zeros. First of all, what is a zero? The values of x in the domain of a function for which f of x equals 0. When you solve f of x equals 0, those are called the zeros of the function. These are real solutions, or what we call roots, of the equation f of x equals 0, and they correspond to the x-intercepts of the graph. So, we have a lot of different ways to talk about the same number. When you let y equal 0 and you solve for x, those x numbers can be called zeros, they can be called roots, and they also correspond to the x-intercepts. Those three terms are synonymous. When you set y equal to 0 and solve for x, those x values are going to be your zeros, they're going to be your roots, and they're going to correspond to the x-intercepts. So the first question, find the zeros of y equals 4x cubed minus 4x squared minus 25x plus 25 by looking at the graph. So you need to go get your calculator out and put that into your y equals. Okay, in the calculator, under your y equals button, you typed in your polynomial, 4x cubed minus 4x squared minus 25x plus 25, and you hit graph. Okay, in behavior, let's go review real fast. In behavior, 4x cubed, odd degree, positive leading coefficient. What's the in behavior going to look like? It's going to be down, up. Keep that in mind. On the calculator, is it down, up? Well, it's going to go like that, right? So it's down this way, and it's up that way. All right, try that again. We are concerned with finding the zeros, which are synonymous with x-intercepts. What are the x-intercepts here? Well, I'm looking at maybe 1, somewhere between 2 and 3, and somewhere between -2 and -3. You agree? Okay, I'm going to do I'm going to go do second calculate 0. So I want to calculate my zeros. Go down to number 2 and hit enter. Now it tells me to find a left bound. I want to go to the left of my 0. So hit your oh, there it goes. Did you see it? Am I to the left of it? Yes. Hit enter. Now it tells me to go find a right bound. So arrow to the right a couple of times and hit enter. Now it tells me to back up and guess. Just hit enter again. What does it tell me that my 0 is? -2.5? Okay, on my graph, I'm going to go do -2.5, 1. What was your other guess for that other one over here? 1.5? I can always also do what's second table. Or I can do second calculate value and type in 1.5 for x. No, it's not 1.5. 2.5. So let's go second calculate value 2.5. Yes, very good. All right, 2.5. You agree with that? So what were the zeros from the calculator? X equals negative 2.5, 1, and 2.5. My x-intercepts are going to be negative 2.5 comma 0, 1 comma 0, and 2.5 comma 0. Do you see how the zeros correspond to the x-intercepts? X-intercepts are always points. So give me an xy ordered pair. We're going to go do it again. I'm going to push pause and let you play on this next one for a minute. Okay, for the second example, find the zeros of y equal x cubed plus 10x squared plus 25x. If I go my calculator under y equals and type in my polynomial, and then I hit graph, are you able to find the zeros? It looks like negative 5 and 0. So my zeros are at x equal negative 5 and 0. What are my x-intercepts? Negative 5, 0, and 0, 0. Here and here. Now, this is a degree 3 with a positive leading coefficient. What's the end behavior going to look like? Down, up. Is that what our graph looks like? Yup. So I'm going to have down and up. Okay, what did you notice that's kind of neat about this x-intercept? What does the graph do? It's increasing, and it touches that x-intercept and then goes back down, right? Why does it not cross and go up over like that? Let's talk about touch points versus cross points. Let f be a polynomial. Let c be a real zero. Then the point c0 is an x-intercept. And furthermore, if c is a zero of odd multiplicity, the graph crosses the x-axis at c. Okay, there are some new vocabulary words. C is a zero of odd multiplicity. The graph is going to cross the x-axis. If C is a zero of even multiplicity, the graph touches the x-axis there. So going back up here, this 0 is going to have what we call an even multiplicity because it touches. This 0 is going to have an odd multiplicity because it crosses. Odd crosses, even touches. So I'm going to go write that down over to the side. Odd crosses, even touches. Remember that. Odd multiplicity crosses, even multiplicity touches. A note that this book gives you. If your multiplicity is 1, which is an odd, so it's going to cross, right? It's going to cause the behavior around that 0 to be linear. Whereas if the multiplicity is 2, it's going to cause the behavior to look more like a quadratic. Like this. That's a quadratic. If the multiplicity is 3, it causes it to look more like a cubic. And we'll go look in a minute. Let me let you catch up. The first example, determine the zeros and their multiplicities on letter A. Y equals -3/5 x plus 3 quantity to the fourth 5x minus 1 quantity to the fifth. This polynomial is given to you as a product of linear factors. That's nice. Because to find the zeros, you set each linear factor equal to 0 and solve for x. So this first one, the x plus 3, actually let's back up. Is this a factor, a linear factor? Is there an x in there? No. If you set that equal to 0 and solve for x, does that do anything for you? No. So we ignore it. So we move to this piece, x plus 3 to the fourth. If I set x plus 3 equal to 0, I get x equals negative 3. That is a 0. Now the multiplicity associated with that 0 is the power up here. It's 4. So I'm going to add another column and ask you, does it cross or touch at this 0? The multiplicity is even, so it's going to touch. Okay, the next linear factor, 5x minus 1 to the fifth. If I set 5x minus 1 equal to 0, 5x equals 1, x equals 1/5. My 0 is 1/5. What is its multiplicity? 5. So it's going to cross at x equal 1/5. So on my graph, I'm going to have a 0 here at negative 3, and I'm going to have a 0 here at 1/5. Now I'm going to go graph that on my calculator to see what it looks like. Before I go there, I'm going to guess what my end behavior is going to look like. I have a negative number out front, an x to the fourth power, and a 5x to the fifth power. So is that going to be a negative x to an odd number? Negative x to the ninth? Okay, so what does y equals some negative number times x to the ninth power? What's the end behavior going to look like? It's going to look like up, down. Exactly. Yes, x to the fourth times x, 5x to the fifth. You add the exponents. Okay, on my calculator, I hit graph. Oh my goodness. Can you tell what that looks like? So I'm going to go play with my window. Maybe negative 4 to 2 by 0.5. I'm guessing that it looks something like that. End behavior is up, down. It touches at this x-intercept, and it crosses at that x-intercept. You agree? Now, all these bumps and how, look right here at this one. This is going to look like an x to the fifth graph. So it's not going to come in linearly. It's going to come in kind of like that. Is that what it did? Right here? All right, go do the second one. Go do B. So I entered the polynomial into my calculator, and I'm going to hit zoom 6 because that puts me at a standard window, negative 10 to 10. How many x-intercepts do I think I have? 1, 2, 3, maybe? Okay. Over here, I'm going to tell you, hold on. Okay, so this is B. It was 2x to the 6th minus 14x to the 4th. Is that right? Okay, if I were to factor that, and I could factor out a 2x to the 4th, correct? And I'd be left with x squared minus 7. You agree? Now, x squared minus 7 is a difference of 2 squares. So that would factor even farther, 2x to the 4th times x minus root 7 times x plus root 7. How many zeros do I see now? I should see 3. For this one, if I set that equal to 0, what do I get? X equals 0, do you agree? If I set this equal to 0, x minus root 7 equal to 0, x equals root 7. If I set this equal to 0, I get x plus root 7 equal to 0. X is equal to negative root 7. What is the square root of 7 approximately equal to, guys? Negative 2 point something? Okay, when I go graph this, my x equals 0 is right here. My x equal root 7 is here. And my x equal negative root 7 was here. Now let's go back to end behavior. What does 2x to the 6th, what is that end behavior going to look like? It's even, positive coefficient, so it's going to be up, up. So I had something that looks like this. You agree? All right, so we needed to go fill out the table. The 0, the multiplicity, and does it cross or touch? So this one, the 0 is 0. What's its multiplicity? 4, x to the 4th. So would it cross or touch? It's going to touch. Is that true right here? Yes. Okay, the next one, the red one, root 7. That was here. That was this one. What's the multiplicity that's up here? 1. Does it cross or touch? It crosses because the multiplicity is odd. And it crosses almost linearly. The orange, negative root 7 is the 0. What's its multiplicity? 1. Did it cross or touch? It crossed.